Here we have day 2 notes, two-step conversions, and now we're going to go from particles to mass. After today, you'll be able to perform a two-step conversion using molar mass and the representative particles, which would include atoms or molecules or formula units, which is just merely one set of the compound. We've already learned how to convert moles into particles and vice versa by using the conversion factor 1 mole equals 6.02 times 10 to the 23rd particles or atoms or formula units or molecules. We could say pizzas. 1 mole equals that many of whatever you have. We've already learned how to convert moles into grams and vice versa by using the conversion factor. 1 mole equals the atomic mass in grams. These two conversion factors can now be combined. We can go from particles to moles to grams. We could go from grams to moles to particles. We always have to use our conversion factors in order to do so. When we're going from particles to moles, we need to divide our particles by Avogadro's number, 6.02 times 10 to the 23rd. When we're going to our molar mass, we have to use the molar mass of the compound and divide that into the number of grams. Here, we're going to use the molar mass, and we're going to, again, use our Avogadro's number to convert the moles into particles. This will become a little bit more clear when you see what's going on in an example. So here's an example. So what's the mass of 1.79 times 10 to the 24 formula units of potassium phosphate? The first thing we're going to do is we're going to do our knowns and our unknowns. So we know we're given this many formula units of potassium phosphate. The unknown we're solving for is how many grams. This may seem silly to always do this knowns and unknowns, but once you get moving through problems that are a whole lot more complex, having these two things down is going to allow you to check your work without doing any, it'll just really reduce your mistakes that you might make. So here's what I'm given, and I put it over 1. I'm going to multiply that by my conversion factor. Well, a mole of potassium phosphate would contain this many formula units of potassium phosphate. I make sure my units cross out. Now, I still don't have grams, which is what I'm trying to solve for, so I know I need to keep going. I also need to figure out what the molecular weight of one of these formula units is. So I have to figure that out as another step. Again, I'm rounding to 2 decimal places. And there's my answer. So 1 formula unit is going to weigh this much in grams. I now plug that into my formula. I'm going to make sure that my units are going to cross off. I've got mole here. I need mole on the bottom. And now I'm to grams. Grams is what I'm solving for, so I know that I'm actually done doing my calculations. Cross off my units. Again, I'm only left with grams, and that's the unit that I need. And your answer will equal 631 grams. So now it's time for you to get some practice. You're going to complete only the odds on worksheet 3.